may remember from a previous class about like terms, so this is kind of a refresher of like terms, but we're going to bring some of our real numbers that we've been talking about, those fractions and decimals and things that we had, into our combining like terms. So that's kind of our new little twist. But remember what like terms are, like 3x and negative 5x. These are considered like terms. These are like terms because they have identical variable parts. That means they have the same letter to the same power, okay? The 3 and the negative 5 part of it don't matter. Likewise, 10xy and yx, those are like terms as well. We can put those in the like terms category. Even though the x and the y switch their order, they're still considered like terms because it's got the same variable raised to the same power. What are not like terms, and we'll put those in a circle with an X through it. Once I write them down, I'm going to go with a different color here. 5xy squared and 4x squared y. Those are not like terms. Put a cross through that. Those are not like terms. Even though they have the same variables, the y is squared in the first one, we call that a term, and the x is squared in the second term, and therefore they're not considered like terms. So when you have like terms, you can combine them, and what you actually do is combine just the numeric part. Yes?
So if it was...
Okay, so if it was...
So if it was 5xy to the second power, and if it was 4xy to the second power, that would be like...
Then that would be like terms, exactly. Yep. Okay, so when we combine like terms, like I said, what we do is we look for the number. And this gets confusing to some people. The operation in front of the number is what is attached to it. So the minus here goes to the 6. This is like 5 minus 6 v. I just take those numbers. Those are the coefficients. I just take that number in front. What is 5 minus 6?
Negative 1.
Yep. So this would be negative 1v. Or we usually just say, if it's 1, we drop it, and we just would write that as negative v. 1 is the only number that we drop like that. So when I am looking at a whole bunch of terms, I can only combine the like terms. And what I do when I'm combining like terms is I like to group the like term parts together. You don't have to physically do this on your paper. I will on my notes, but you should do this in your brain. The 3x goes with the plus 1x. Wait a second, where'd the 1 come from? Yeah, if we don't see that number in front of there, we assume it's a 1. Okay, and then the next group would be the minus 2 and the plus 7. So I treat that as minus 2 plus 7. I actually treat that like negative 2 when I'm working with it. Do you remember doing that, changing a minus to plus negative? Does that ring a bell? I don't ever do that here. I don't write plus negative here, but I'll take that minus and treat it as a negative. So I have to do 3 plus 1 x, and then it'll be plus negative 2 plus 7 is how I'm going to be thinking this in my brain. And again, you don't have to write this out. This is what you're thinking in your brain. So what's 3 plus 1? 4x plus, what's negative 2 plus 7?
5.
Great. And so there's my final answer, 4x was 5. A lot of times we have the urge to keep going. Like, I'm on a roll, I'm just going to keep combining, and so I think this must be 9x. No, because the 4 has an x and the 5 doesn't. I cannot combine them together, okay? They stay apart. Yes,
In other words, x is equal to x is not x is equal to non-x.
exactly.
And you either add or subtract.
Right, and so you'll have as many different variables as you have in their terms, yep, or non-variables. Very well said, very well said. Okay, if we have fractions involved, the rules don't change. We still deal with it the same way. It's just sometimes a little scarier because now we see fractions. These are still like terms because they both have an x, but instead I'm going to do negative 5/4 plus 1/6 x. And now this might have to be plugged in my calculator. Do you remember us doing the fraction key on the calculators?
Yes.
Okay, good. So I'm going to go ahead and do the fraction key. On these blue calculators, the fraction key is 1, 2, 3 buttons above the 7. It's the ABC button. If you have a different calculator, yours might be in a different location, and if you can't remember where yours is, just let me know. But when I plug this in, I'm going to go negative 5 fraction 4 plus 1 fraction 6. Get that answer. It's negative 1 1/2, so I write negative 1 1/2 x. Negative 1 1/2 x, and I'm done with that problem. Wait. Did I do something wrong?
Wait, how did you do on the calculator? Sorry.
Okay, that's okay. I did negative 5 fraction 4. And I think yours is the calculator. Do you have my oh yeah. You have a different one, right?
Yeah.
So you have to put your negative in last. So you do 5 fraction 4, then make it negative. And then plus 1 fraction 6. And then I get my answer, negative 1 1. Is it 1 1/2? I did that same thing in the last class too. Is that what you guys were thinking?
Yeah.
Just gotta yell at me, sorry. Yeah. I didn't see the 1 again. And that was the same thing. I did the same thing in the last class. Different problem, different work, same thing. It was a 12th in the denominator. Okay. So if you have multiple values, again, you have to group the like terms together. Not necessarily physically on your paper, but I will on the notes. The 37/10 r goes with the minus 7/4 r. The minus goes with the 7/4 that's in front of that. And then next to that I have minus 1, minus 4. So I'll do 37/10 minus 7/4 r plus negative 1 minus 4. Remember that minus, it goes with the 1. So 37 fraction 10 minus 7 fraction 4. 1 19/20. And then negative 1 minus 4 is negative 5, plus negative 5 makes this minus 5. So 1 19 r minus 5, final answer. Same thing goes when we deal with decimals. The same rules apply, it just looks a little bit different. So please trust in your calculator skills. As long as you carefully enter them, you should be okay. Combine the like terms. What goes together in this problem? The negative 8.3 and the 3. Yep, so it's negative 8.3 plus 3k. And then what else goes together? Yep, the 3.6 and the 5. So plus 3.6 plus 5. So I'll trust my math skills or my calculator. Negative 8.3 plus 3 gives me negative 5.3k plus, looks like 8.6. How does that look? Pretty good? Feel okay? Yes. Yeah. Can I what? Yeah, for sure. for sure. Yes.
What do you get from the power board?
Oh, sorry, I'll back that up. Yep. How do you feel about that? Okay. All right.
Where's my five?
Keep in mind that it's a -1 and a -4. You're taking away 1, Tyler, and you're taking away 4, so that would be
No, I'm
Five.
talking about,
Oh.
for five.
for 5, okay?
Why is it negative 5.3?
Because it's negative.
Because negative 8.3 plus 3.
Oh, never mind.
You good?
I
Okay.
Actually, 0.3.
Oh, okay. All right. Now, there is going to be an occasion where there are some terms that have like terms and some that don't have like terms, and that's okay. In this last one, I have a positive 6.6a and a positive 3.819a, but this 0.5 sort of hangs out on its own. It doesn't matter if you write it first or last. Typically, I write the letter terms first, so I'll do 6.6 plus 3.819, and then I'll put the a after that, and on the end, I'll add the 0.5. I said typically that's the way I do it. But it doesn't matter if you put the a term first or the a term second. That doesn't make any difference to me whatsoever. But I do have to calculate these real numbers that are in decimal form, and that's 6.6 plus 3.819, and I get 10.419a plus 0.5, and I have to stop there. All right, so you guys are going to work on a worksheet, evens or odds. I will hand that worksheet out, evens or odds.